Our final flash talk is from the chair of the computer science department at USD. Please welcome Dr. Casey Santosh.
Check. So my talk is going to be all about AI is the deal breaker. It says something different, but that's what it is, right? I'll give you an idea. It's going to go in two parts. Number one, I'm going to tell you AI is not for computer scientists. We will develop for somebody else, which we have seen since the beginning of the day. Industry, right? He's gone. I don't know what is wrong. Industry, academia, right? We'll have to go back to the government, state. I'm going to give you a nice walkthrough about where AI/data science should be used. If you are not looking at AI and data science tools, and you're not a computer science major, basically you lose something. That's what the talk is about. Computer science major's mind. If you're a biologist, here is the deal. And you are deprived of your lack of using AI tools. In 5 to 10 years from today, you're not in the business. You know what I'm saying? That's what the talk is about. So, and the second part is going to be the real world case. A few cases I'm going to come up with. And those cases will tell you machine learning is not just about building models, right? So in other words, we call building models is not an innovation, right? You get it? So what we need to do is active learning. And I'm going to put you in the hype of big data. Everybody wants it, but I will tell you why it is not required. And second, carbon footprint. The reason is it is a time for computer scientists. I go back to computer scientists to think about optimization. You are rich, you can buy any number of supercomputers, don't mean that you produce carbon. You can't do that. So let's think carefully, be a little more mathematical, and look after optimization. You can't have a lot of neurons play around and have this small thing done. You just have to use the right tool, not at the cost of using a lot of electricity. I'm talking about consumption energy, right? That's what we're looking at grid computing. More or less ambitious, and I'm going to make it a little slow. The reason is the last speaker is on the way. I'm going to take a look, right? When she is in, I will stop. Make a deal? Let's move. I should be nearby. Every speaker has this problem, by the way. It's not just me. What we do in the past is just do that. Sometimes it works. It doesn't work. Maybe, Tyler, you want to help? But where's the point of being close? Oh, yeah. If I'm close to a computer, what is the point of having this seat? So, come on, man. Okay, I'm here. Good. So here, it's all about me. No blame to my institution. Okay, everything is all about me. We discuss, we do talk, we ask, we share. And academicians, they always are proud of the property they have. No housing, no real estate, or books. So here is the thing that I would like to tell you. Back in days, we believe and we rely on computing. We say research in computing. We didn't say all nice buzzwords like AI and machine learning. Who doesn't want to use the buzzword today? Everybody. So it's all about computing. That's why, if you look at research in computing, energy comes first, agriculture, economy, education. If I see healthcare, I miss somehow, that's what's in red, where my whole energy today is in research, mostly in healthcare. It's because I don't have to tell you, it's all about where the money comes from. Since the day you're born, you definitely have to get registered, healthy, not healthy. We got a lot of data, we analyze, we see what comes next, right? Healthcare is the domain for AI scientists where there is no stop sign. There is always money, we always have problems, and I'll come up with future epidemics at some point. So I don't want to talk about all my stuff in here, but at the same time, let me start with this one. Like you said, it's a walkthrough. Computer scientists will, and they always develop algorithms to do certain tasks. One is healthcare. You see some problems here and beautifully made. You have seen some anomalies in chest X-rays, right? We used to call back in days heat map. Today, we use nice term explainability, right? Or in other words, we can call it future map. The representation of where, let me be a little healthcare people, a representation where I show you clinical manifestation. How about that? Due to disease X, maybe COVID-19. Cool stuff. I see some problem here, maybe not, and here. The deal is, if I'm not making a one-way decision here, I still have doctors like Dr. Gundati and Dr. Chen. They will decide, basically I'm giving him a second opinion. How about that? So they can sleep 5 more minutes in the morning. So they don't show bad, sad face to customers on the way. Right? I give you some time to sleep. So that's what the AI is about. So this is how we do, right? One area to work. Second one, I still remember when we got this free COVID back in 2020. The state, South Dakota state, people look after all mathematicians, right? Then you, me, and so many other people in the state, we got together, they brought us together and talk about what should we do? Can we predict what is next? That visualization is still today, 98 days. We are basically in summer. I was in the basement watching these people and talk all nice stuffs. And we'll come up with something. This is data visualization. It's not predictive modeling. Long story short, I do data visualization for first 98 days about COVID-19 to see what comes next, right? But we forgot a data distribution. A mathematician requires a complete data set to understand what the population looks like, so I can come up with the model, right? For first 90 days data, and you want to predict something, obviously you can't do something cool. You still predict. It's because having a pressure cooker in hand, you're cooking something, don't mean that you really cook. You know what I'm saying? So we still predict something, but I know what's going on. We know. That's why I come up with the book saying at some point is, this is data visualization, not the prediction. But still, there's something we need to work on. Let's not talk about, I will tell you, the need of data distribution and the understanding of data distribution is important for machine learning scientists, which is probably me. So the second other stuff, digital humanities. Think about those documentations or documents we have here in South Dakota, mostly Native Americans document. Do you think at some point we should digitize them? We should have a very nice auditorium like this and you sleep like, astronomy. And those documents, they fly over, digitized fully. and somebody speaks for us, and I sleep nice, cool, calm, and I hear everything about what things going on. We should be doing that. That's what digitization starts in here. In this case, since I came from document imaging background way before, this is me doing, by the way, I didn't copy from anywhere else. Way before, I used to look after signature verification. I look after logo detection. I look after stamp or logo verification when they're different. I look after everything handwritten on top of machine printed characters. Look, now I'm going to back to a doctor's report at the same time, how important it is for document image analysis, right? Same thing, digital humanities, where it comes to graphics. Those graphics, ancient documents, beautifully made, and they have a meaning. That's what my part of my PhD way back. So it's beautifully done. And here's the book. The book is all about this. Let's not spend time. And I'm going to go back to here. It is not just that much we can do. We can do up to here. Today's Google map you have is not just because you have satellite just revolving around and get the data. Here is what it is. It's not just about that. We did task. It is about graphics and text separation from those ancient map. Have you been anybody in your family in veterans army? This that I used to be reading maps. You know, those hard copies in the pocket. Look where I have to go. Those maps we use today and digitized fully in a way that it is in your GPS in your mobile phone today. You see what I'm saying? We did really good task over time, over years, and today you have got nice GPS. Everything is 3D. Of course, satellite images is helping a lot these days. Here is the doctor's report, Prince document. What it says is, if you really want to learn everything in there, in this document image, you basically have to know what the graphics are, where they are, where these handwritten characters, and where are the machine printed. Reason behind this is, it's important to understand we should have two different optical character recognition engines. One for handwriting, the other one is for machine printed characters, of course, and these are language dependent as well. The friends should be different. So it's beautifully done way back days. Again, when it comes to AI, it is important for us to understand ethical issues, responsibility. We'll talk about accountability and interpretability, right? Interpretable AI is useful to understand what is in the black box. At the same time, it is important to see who is accountable if it goes wrong. If you look at ChatGPT, everybody is happy using this ChatGPT for this and that reason, which is beautiful, right? But who is responsible if something goes wrong? So we talk too much about responsible AI, but when ChatGPT comes into play, people will stop talking and they talk about all other seats, which is not right. So let's talk about accountable AI. Who is responsible if ChatGPT kind of open AI gives you something and you do that task and people die? Possible, right? It is important to understand for us is what happens if I deploy a system just before the day of the election. That would make a change. That's why responsible AI is about who are the users too, not just the system, right? So let's talk about this here. Let's talk about automation. You know, now I did everything, basically all nice applications. Now come back to how automation happens. Is the automation AI? We'll see. Do you think this robotic stuff AI? Probably not. It's just an algorithm. He does the task every day, the same thing. That's not AI. AI should be more close to humans, right? More close to human. If I say my boy, kick that boy, other one, he's not going to kick his friend, but the other one, he probably can kick. This is an automation. This is not AI. If I really want to have a system mimicking me or you, that is an AI, not just the robot. Robot is going to do exact same thing over time, regardless the way there are any conditions, right? So in 100 years back, Frankenstein was worried about, what if my boy, meaning my son, play in the backyard and some of the robots, they get together and kick his ass? It's because he was worried too much about they can talk. We call swarm intelligence. He was worried, but again, there are some people that are so fond of making robots. We call humanoid, and today we can have girlfriend as humanoid. We can have a baby. He can walk all the way to a supermarket because I can turn it on. He can walk with me all the way to supermarket. He's not going to ask anything else beautiful. And I'm saying nothing to buy. Beautiful thing. Come back home. I'm tired. Turn up the machine. I go sleep. He's going to sleep too. It's possible because we still have humanoid. I don't want to be more adult in here because we still have partners today. Right? Which is a beautiful deal. So here, playing soccer or football or whatever, it's beautiful to see. It's all about perfect world. This is good because I have nobody to play with. Fashion industry. It's useful. It's possible to happen. It's useful. It's going to work out. Again, what is this? Look at, I don't have any dog or no, so I'm going to make a robot pet. He can walk with me whenever I want. He's going to play with me, which is beautiful, but more sentimental. This one is looking nice because I feel more sentimental here, but if in the perfect world of AI, this is beautiful because we have advanced. Again, fashion industry, beautiful. How about this? You may like it. It's because we definitely help disabled people with the help of robots. Example, telesurgery or robotic surgery. This is also beautiful, but others, it just gives us a different feeling. What? Because we're too much sentimental. We're not looking at how AI has been advanced, right? So back here, again, this is my quote all the time. You're the future of AI, that's our future and all is bright. You see so many applications, but the brighter it becomes, the more sad it gets. That's okay, we'll take it because we move on. Now, I will take 10 minutes more. Amy is here? Not yet, so, okay. So you raise my hand and I will stop because I have too many things I can go for a day. So, but let's talk about real world problem because I give you the part one is done. You understand the power of AI, right? Once you become the palm, this is cyber security, this is healthcare, this is agriculture, this is business industry, this is housing industry. They definitely have to come reach you because you are an AI person. That's what the AI is, because I take AI is palm. Fingers are applications in which we will use whenever we want to use. That's why I become. If you see me all the time, starting document imaging all the way to prediction, and now we're talking about future epidemics because I'm more into healthcare. Why? Money's there, right? So infectious disease, I say AI is inevitable, so does future epidemic. So that we have to accept it because we produce carbon, we do this, we cut down the trees, we do a lot of good stuff. Let's talk about real machine learning. So I tried to make you understand what machine learning is about. And I don't like people just building models. That's I call in different way. Building models is not innovation. If you don't know what the data looks like, if you don't see a complete data set, you don't definitely learn nothing. You learn something, but it can come up with some results which is not expected. You always have results, but that's not expected. That's why data distribution is important. And I take just a simple one so everybody understands this camel hump. We call Gaussian distribution or normal distribution. Easy, right? If I see the tallest one, it means most of the population, most of the data points there talk about the same thing. If I have this distribution, the blue one, I can predict something cool because they are consistent enough to talk about something, let's say some specific event. But if I have the flat one, they don't talk. That's why back in days we call flatten the curve. It's because they are sparse. He is talking something different, the other one is talking something different. If I use that kind of data for prediction, obviously I don't go right. I need to have data distribution. This should talk about exact same thing that I'm looking at. So I predict right? So what did I tell you is data distribution is important. So machine learning requires cool amount of data, right? That's what I tell you. Most of the time we don't know. So it means we have a cool amount of data, meaning large data. We train the model. This is how machine learning goes, which is everybody understand. And we get the results with the unknown samples tested on trained models. I say deep learning model is because deep learning is famous, so why not we take the sexy word here, right? It's beautiful tech. So here, let's take it one way around. Take a human as an example. A baby start learning over time, get learned, and go for the taste, and have the results, and go to symmetry. Is he coming back and help somebody learn? Same thing, always start from here again. I learned something. I taste over time because I keep going. I have to go to symmetry one day. That's what the natural process is about. And he's not coming back. We always do the same thing over and over again, and I'm not happy with that. What we should have is closed loop control system. What he learns should be teaching to somebody in the form of generalized AI. What does it mean is what he learns should not be wasted. Right? We got that many neurons to learn, and we learn a lot. When somebody says, I'm going to give an example for that one, so that's in real estate. So how much data I need then? Then people come up with the idea saying that I need big data. So when I was looking at all machine learning scientists across the globe, I come up with this sarcasm paper, how big data is big for you. I feel like I'm going to chew him, but you know what it is. So if you look at your scholar, if you really implement, look at yourself first. If you don't implement, you ask your scholar to implement, then ask him. And he's going to tell you, he or she, they're going to tell you that I need a little more data. Results are good, professor, but I need a little more data. He is going to believe, professor is going to believe and give him more data. And he said, it's too complicated. You think he's going to make you 100% accuracy or performance variable comes into play after you add more data in the game? It's not going to happen. So it's important for machine learning scientists to understand how big data is big for us to start. So we keep learning, right? That's why I say this is all about the things that we just want to blame, not wanting to blame on ourselves. We just blame somebody. One day I say I need more data because results are not good. Second day I got enough data, but I still say more complications happen because of more data. What is important for us to know is that data should be enough. What do you mean by enough data? It means if you're looking at clinical manifestations, right, for certain disease X, at that point, you just have to look at all possible clinical manifestations, meaning how many times you need to have capital A to be right. 10 times enough? 100 times enough? Maybe that's enough. Otherwise, my son is going to say, come on, how many times you give me the capital A? I already learned. That's not. So we should be able to stop at some point that I have seen all possible cases. I don't need more data. Who's going to tell that? Right? That's important in healthcare. Let's do this one. So back in days after COVID-19 been announced, the second day I published this paper, and it's been a top 1% popular recognition, whatever, in clinical medicine from AI side. What did I say is you need active learning. That paper, it's an opinion paper. Just the second day after Dr. Fauci announced that this is COVID-19, the name, right? The second day this paper was published and it's very popular is because we need active learning framework. What did I mean is it's the machine learning model with the expert or human in the loop, right? That's important. So what it means is over time you collect data, you're not going to wait 2 years. You're not going to wait data for 2 years, train the model and test it. And yeah, I got 98%, my friend, by the time all people die. So what is important is to make sure that I can make the model ready to get trained from the first day in parallel with the experts. I would like to repeat here, our experts were not COVID-19 experts. They were infectious disease experts. What does it mean in our machine learning lingo? We have a pre-trained deep learning model, which is very close to infectious disease expert, which is analogous here. I am trying to compare. Infectious disease experts are also pre-trained for COVID-19. So I also have pre-trained model. He can learn, why not me? Why not he helps me on the way when he's learning unusual items? That's what the idea is about for all possible data types. So one model, one data type, which could be, I have Nick is here. Is my cough sound COVID-19? Where is Nick? Here. Is my cough sound COVID-19? We published this work. Cough is one data type, right? And the second one is chest X-ray. Third one is CT scan, chest CT scan. Possibly varieties of data type, too many. So we can have this one. If I make mistake, I means machine, then the expert that day will watch me close and, oh, you make mistake, and here is the feedback. I get the feedback. Did I say that conventional machine learning, get the data, train it, test it, and go to symmetry, never come back? That's not the machine learning we want. We want machine learning in a generalized framework we call generalized AI, which is close to human intelligence. In healthcare, we try to see AI not as artificial intelligence, but as augmented intelligence. It's still AI. So that's why we did talk with Dr. Gundetti yesterday night that we should change somehow nomenclature. When you see some domain and this and that, probably we come up with something. Let's make a deal here. It is not just one data type. My saying is, if you look at here, as we talk, if you look at this data, they come from sensor-based or machines, wherever data, and this one is image data. This one is document imaging because doctors write all crazy. Nobody reads that, right? So we need all tools available to make a decision about that particular event. The event could be HIV positive, could be COVID-19, could be anything else. So what happens is, if I take all possible modalities, meaning data types, it is beautiful to have a decision with higher confidence. It is not just testing cough sound. It is not just limited myself to go for a chest X-ray, not just the prescription at the end. I take everything from here, starting from the morning, talking to somebody, maybe clinical doctors or nurses, somebody, all my voice, pitch, sound, this should be recorded. I'm thinking about smart healthcare at some point in the States, right? All these data talk about that event that I'm carrying to be tested. End of the day, they will come up with the results, and they should be consistent enough. There are some outliers. That's what we did talk about, weapons of math destruction or something. Jen and I, we went through this book at some point, I think last year, so a couple of years back. So let's take the consistency check, let's do consistency checking here by taking all different sources of data about particular event E, right? Let's take it this way. And this is about how they connect, how the data connects from each other, coming from different sources. And this is decision making with no bias. Doctors always pat you, Casey, don't worry. You got COVID-19, but don't worry. Right? So we shouldn't have this bias. There is no time to talk about it. The machine is going to say, you win. All right? Positive, negative, that's what we need because we're looking at mass screening, meaning population. I'm not talking about just 2 or 3 people with population. So otherwise, that's not good. In real time, we don't have that much data, right? What is necessary is active learning. We're not going to wait for 2 years. And you can think, how can you build a machine learning model not having a data? How about the human? Beautiful couple, a kid here. By the way, I'm going to take a name of my scholar who's been working on this project for years. So kid is in here. He's going to be a little bigger. These parents will be mentoring him all the way up to 18 years. You think that's the end of the day? He doesn't have to learn after that? Why did we say mentoring is done? Now you're free to go. The magic number 80. We will do the same thing for machine and see where the machine behaves after mentoring is done. How about that? That's what the idea of agreeing to disagree. We published this paper some time ago. While we do mentoring a kid, over time, he's not going to be agreed. Sometimes he's going to be, he was disagreed before and agree now. And agreed before, disagree now, because he learns things too on the way. So 18 years, magic number, we're done. That's what we call active learning, meaning with less amount of data, day 1 collection is enough to start. Don't wait for 2 years, because by the time people die, there is no meaning to get things done. So I would love to see this work published as soon as possible. We're in the process, and Supreme is my research scholar who implemented this concept, which I've been working on since 2020, March. He implemented this task beautifully. Reason is we need data to take a look whether the concept is going to work. So our prototype was ready. So I'm happy to talk about this. You have data over time T1 to these. So we got too many data types. Like before, we talk about multimodal learning and representation, right? And we have deep features. Don't worry about deep learning. Everybody using that. I don't care about this because the pre-trained model, which is here. We make decisions in unsupervised framework, and we only get mentoring when we commit a mistake. Meaning when machine makes a mistake, there is a feedback from doctors, no. You know what I'm saying? This is wrong. Then the system updates day by day, sample by sample. Again, the idea is to have expert in pair with the machine, watch him, whether he does right. Day 1 collection, 40 samples enough to start. Right? So how long we do mentoring, when to stop? Like 18 years. He still can make mistake, but we believe that he's going to learn by himself. That's what the idea of active learning we call human in the loop. So we take the idea of, we take 2 different data sets, because looking at multimodal learning representation, right? So these 2 different data sets have some clinical manifestations. Back in days, I worked on a cross-population train test model. Reason is, when data is scarce, you don't have enough data, you basically have to train a model from Brazil, and you probably want to test that in Italy, or Japan, or Germany, right? So it's important to take a look. Back in days, in 2020, I see whether we can do it. But healthcare, mostly doctors don't want to do it. It's because demographics change. The body size, these, that, too much change, they don't like it. It's because healthcare is very sensitive domain. Computer scientists, am I going to lose? Let's take a look. So we see a silver lining in here because we got good results from this performance. So if you look at here, this is mentoring. I did talk about this. And if you look at the mentoring or mentored subset of data, you basically have to start with 160. So the first incoming 160 samples will be mentored, will be watched. Why there are systems making mistake. Second, we increase up to 360, all the way to 1510, because I keep watching whether he's doing right. I'm an expert, right? Once he is good, I don't have to mentor anymore, okay? So here, this is unsupervised framework. We don't want to talk about this. I go here, and we didn't really make that much mistake. If you look at here, these are the published papers with the large amount of data get trained, okay? Get trained, and this is the model that we have with no training. We're starting from 40 samples on first day and have mentoring just looking after him all the time. Oh, now you get to go, you fly, and he's got the similar results. Look at this one. So it's beautiful. This concept has been validated. Active learning is the must when you don't have enough data to work on. And you're not going to wait for 2 years and people die. You come up with nice models, so what? You go play soccer. People die, already have died, right? So this basically, that's the idea. So this is, again, you take back, revisiting. Big data, I'm gonna finish in 2 to 3 minutes, okay? Big data always brings supercomputing stuff. When you have to analyze big data, we look for clusters and make decisions. This is here. And big data is basically complex by nature. Too much redundancies. You don't need. Do you think Tesla must be accountable for us? They must be accountable. Now, we don't have to pay tax. They will pay tax for us because that was carbon dioxide products. Data centers, meta data center. Look at the building is all about computers, by the way. We're not talking about cars. We're not talking about all electric, systems and so on. About this? It's a lot. And you see the numbers in here. That many megatons. I don't want to take a look and talk about big companies because I don't want to take things in a different way, but you understand that there are ways to optimize things. Number one, finding the right tools. You have 2 problems for students. Number one, to drink coffee. Second, cleaning driveway. We did clean driveway a lot this year. And you have these tools. Which one you want to use? Shovel for coffee, spoon for driveway cleaning is not good. That's what we do all the time. Every time deep learning models for this one, deep learning is shovel. Can you just use deep learning wherever it is really required? Even a spoon is enough. That spoon is enough for your task to be done. That's why, as an editor of machine learning journal, I hate to see deep learning papers when the shallow learning or traditional machine learning tools can make a deal. I will do Dix rejection second day. The guy is going to be surprised. That's why it is important to see spoon is enough for this one, not the circle. Otherwise, people will laughing at you. Here is the generalized AI. Like he said, when humans, they start growing, they keep learning. All these neurons we have, they learn everything, every day, every second. But if I say, Romana, let's go to coffee, she's going to use certain number of neurons just to make decisions. That is we call generalized AI. She's got NLP tools in here. She's got text analytics. That's what NLP is about. She's got all these time series data, numbers, all these things. She knows everything because she learns every day. But when I say, let's go to coffee, she uses some of the neurons that get triggered and make decisions. She's not going to use all neurons that she's got to make decisions. That's what we need to have today, right? That's why I don't want people go to cemetery after getting things learned. Somebody has to come back, have the same neurons to somebody. That's why science fiction movies basically work really good for people who are ambitious in making generalized AI for today. When I say this, that's what Romana is using. She uses this neuron, this neuron, this neuron, this neuron, get connected, make a decision. Beautiful. She didn't use that many. But it's still, we have that many neurons we don't have to use. Like he said, finding right tools would make a deal in terms of not producing much carbon print. Okay, we can reduce. So who can do it? Mathematicians. They know which neurons need to be triggered. Why am I going to use all these large network for simple enough decision-making problem? Simple, right? Very simple. That's what it's about. So if you want to join me, basically, I'm looking at this small time because I love to run, right? And these are things that we do in my lab. I'm more ambitious, and I do more opinion kind of conceptual research with implementation, of course. And this is me. Thank you very much. Yes, please.
So I like the analogy.
Questions.
I like the analogy of how you feel about the learning. That you learn, you become master, then you go to cement. Right? That's exactly. And what we're trying to do is even behind what we have learned. Right? You do journal, you do books, you do everything. But I think the platform we create in here with machine learning, that is the best thing we living behind, either it's you or surgeon like me or researcher like this. So how can we do this surgical training or surgical experiments in a format we leave it there for centuries to come?
Correct. So it's and thank you. Another ambitious question, right? So what I would like to see is to develop domain-specific generalized AI, right? So a surgeon is also a dad. He's going to listen to kids' voices. So we can't make it down the next day. But if I make a domain-specific generalized AI, one day they connect and we'll have large set of neurons doing all kind of stuffs. And that's what the ambition is about. I don't know what's going to happen.
Yeah, I think it makes sense. Otherwise, the skills will be lost.
Correct.
Or the variations of the surgery or
Thank you very much.